let's find out the antiderivative. First, we use substitution. Tangent x equal to t. So tangent x is equal to t cube. So x is equal to arctangent of t cube. So dx is equal to t cube square. So t to the 6 plus 1. Differentiate this inside. 3t squared dt. All right. So now I say desired integral is equal to just t times this bit, 3t cubed, t to the 6 plus 1 dt. Can we further simplify that? So if we let t squared equal to u, we immediately have du is equal to 2t dt. If I rewrite t cubed into t squared times t, right? I have t times dt, right? T times dt is equal to half of du, right? Half of du. So the desired integral this time should equal to 3t squared becomes 3u. T dt becomes half of du. Half du. T to the 6 becomes u to the 3 plus 1. Right? So I put the 3 outside. Okay, so this should be easy for us to use integral by partial fraction. Right? Partial fraction. So that is to, first of all, I use standard factorization. U squared minus u plus 1. Okay, that's the easily verifiable. Now notice this quadratic equation, determinant is already negative. So when we apply the formula, we separate the fraction. So u plus c, a, some constant to be determined, plus the other factor. And I have b times u plus c. A, b, c to be determined. I only look at the top. Common denominator is this times that. So top becomes this times that plus this times that. So this time top becomes u minus u plus 1 plus u plus 1 times bu plus c is equal to just u. So let's look at the square term. Coefficient a is a coefficient, b is a coefficient. It's a plus b, u squared. U term, negative a, b, c, so plus b plus c times u, constant, a, c, right, equal to u. So they always equal to each other no matter what. So which means there's no square term, right? No square term here, no square term. So a plus b, 0. U coefficient is 1. So this is equal to 1. No constant term. So a plus c is equal to 0. So from here I can see a is equal to negative c. So from here, negative c, plus. So b plus 2c. So from here, what can we tell? A becomes negative c. Negative c plus b, 0. B is equal to just c. Right? So b is equal to c. So 3c equal to 1. So c is equal to 1/3. So A is equal to negative 1/3. B is equal to C, 1/3. Okay, so this time A is negative 1/3. B is 1/3. C is 1/3. Okay, so this is in fact this bit integrand. I still haven't multiplied by this yet, so all I have to work out is this bit. Right. So common factor here is 1/3. So 1/3. Still negative 1. Still u here is plus 1. Okay, so there's 1/2, of course. Okay, I've just made those substitutions. I'm going to substitute back in the end. And to deal with this, and this should be easy to work out. And this looks like the derivative log of this bit. Because if I differentiate this, it'll give me 2u minus 1. Now, not exactly u plus 1, so what do? I multiply by 2. Yeah? Divided by 2 as well. 2u minus 1, so minus 1 becomes plus 1, 2 becomes minus 1 plus 3. Minus 1 plus 3. Like I said, this time, this bit should be easy to work out. And the rest is just this bit. Right? So the question is, how can I rewrite this into perfect square? So u squared minus u plus 1 over 4 plus 3 over 4. So that way, this is perfect square. U minus half square plus 3 over 4. And so I can further factor out 3 over 4. Right? 3 over 4. 4 over 3 this time. U minus half square plus 1 right, this time. And to further rewrite into 4 over 3 becomes 2 over square root of 3 combined with this square, right? So distribute 2 over square root of 3 onto u minus 2 over square root of 3 times half. Right, half. That's 1 over square plus 1 this time here. So like I said, this time I can first work out this over that, right? So 3 over 2 u squared minus u plus 1 du is now easily 2 times 3 over 4 times this bit plus 1. Yep. So this times that, 2 times this, 3 over 2, 3 cancel with this 3. Good, so 1 over 2, flip that up in here. All right, du. This time, what is that? 2 times arctangent of this whole bit. 2u over square root of 3 minus 1 over square root of 3 multiplied by the reciprocal of this constant, right? So multiplied by square root of 3 over 2, right? And square root of 3 over 2 times 2. 2 and this 2, they just cancel out. Right? Square root of 3, no problem. Plus c later. First, I have to work out this bit. So 1/2. This integer negative log u plus 1. U is t squared. T squared plus 1, always positive. So this is no problem. And plus, first bit is the easily log u squared minus u plus 1. Like I said, differentiate this automatically gives me that. Of course, multiply by this constant. So 1 over 2. Don't forget that. And this bit, like I said, easily just this bit, right? Just this. So plus square root of 3 arctangent of this bit 2 over square root of 3 u minus 1 over square root of 3 altogether. Right, altogether multiply by half. So substitute back. U is equal to, like I said, u equal to t squared. So t squared equals, so u is equal to t squared. So this square, so tangent x to the power of 1/3 squared. So 2 over 3. Okay, so this time that should be equal to negative half times log of u plus 1. U plus 1 becomes tangent x to the power of 2 over 3 plus 1. Right? Then plus 1 over 4 times log of u squared. U squared is this square, so tangent x to 4 over 3 minus u tangent x to the power 2 over 3 and plus 1 bracket. Okay, this is log. So half multiplied by this bit. Okay. Half multiplied by that. My arctangent of what? 2 over square root of 3 times u tangent x to the power of 2 over 3 minus 1 over square root of 3 bracket. Yeah, that's within the arctangent. And plus c.